when you're looking to find these pieces of information, first, the stretching factor, we take the absolute value of whatever the multiplier is in front of the trig function. So the absolute value of -3 gives us a stretching factor of 3. Because the secant is based off of a cosine function, the period is going to be found by taking 2 pi and divide by whatever the multiplier is in front of the x, which is a 5. And so we get a period of 2 pi over 5. Now, the phase shift, what we want to do when we calculate the phase shift is we want to transform this slightly. The easiest way to find the phase shift is if we remove any common factors inside the trig function. So my -3 stays as it is, secant of, and if I take out a factor of 5 from those two terms inside, I get x minus a 6 pi, and then that whole thing plus 7. So if I think of it in this form right here, it makes it a little bit easier to see. The phase shift is the value of x that gives you a 0 inside the function. So you could just set the 5x minus 30 pi equal to 0 and solve, but if you factor it out this way, it's a little bit easier to find because our phase shift is just 6 pi. And we would have gotten the same thing here. We could have added 30 pi to both sides, divide by 5, and you'd get 6 pi. So either way is fine, but again, this is a little bit of a shortcut. And the units are going to be, again, when you look at the value of x, it gives you a 0. Here is a positive 6 pi. So positive means we're going to shift it to the right. Okay, the relative minimum and relative maximum are going to occur when you add the corresponding cosine function's amplitude to its midline. So if we're looking at the graph of this, so to sketch the graph, what we're looking at here is we take our vertical shift of plus 7. So that means our midline is going to be right along here, okay, at up 7. And then our amplitude is the absolute value. The stretching factor here is 3, so it's up 3, gives me to 10. So for my corresponding cosine function, my maximums are going to be at 10, and my minimums are going to be 3 units down at 4. Okay, and so my graph's going to, the cosine function is going to oscillate between 10 and -4. So once I have my cosine functions maximum and minimums, I know that a cosine function is going to oscillate between 4 and 10. What I can do is I can use my shift, which is 6 pi. So I'm going to go ahead and kind of move. Here is 6 pi, let's say. And so that's where I'm going to take my shift. And I need to see the period. The period is going to be 2 pi over 5. So that means that this graph will complete one full rotation between 6 pi, and then I'll add 2 pi over 5. So I need to turn 6 pi into fifths. So this becomes 30 pi over 5 is equivalent to 6 pi. And so if I add 2 pi over 5 to that, this becomes 32 pi over 5. So I know that my graph is my cosine function is going to repeat between those two values. And so what I need to do with my cosine is I need to find the 5 critical points. So here's 1, and here's the 5th critical point. So there's going to be 3 other critical points in between these. They're going to be halfway between, and then each of those have it again. So halfway between 30 pi over 5 and 32 pi over 5 is 31 pi over 5. So that's my middle critical point. And then halfway between each of those is going to be my other critical points. So I'm going to have to go ahead and go into tenths now. So this is 60 pi over 10. This here would be 62 pi over 10. And this one would be 64 pi over 10. And so I can find these other two halfway points, these other two critical points, by splitting these in half as well. So 61 pi over 10, and here between 62 and 63, or 64 pi over 10, would be 63 pi over 10. So here are my second and my fourth critical points. Okay, so I'm looking at those. I'm going to go ahead and just leave them in these forms, the tenths, for right now, but those are going to be my critical points. Okay, so I know that because I'm dealing with a cosine and it's a negative, I know that the pattern for my negative, normally in a cosine function, I go from maximum, midline, minimum, midline, maximum. Okay? The fact that I have a negative means that this is going to get flipped. So I'm going to go from minimum, midline, maximum, midline, minimum. So this is what the cosine function is going to look like. So if I come back up here on my sketch, I know because it's a negative, I'm going to start at the minimum. So at this critical point right here, I'm going to have a minimum, which is 4, and then midline, and then maximum at 10, then midline, and then minimum. So this right here is, again, from here to here is one period of the corresponding cosine function. Okay, and what that means is at each of these points where that cosine function passes through my midline, I'm going to have a vertical asymptote for my secant function. So if I sketch my vertical asymptotes here, where that corresponding cosine function passes through my midline, what I can do to fill in the sketch of my secant is everywhere I have sort of this maximum in my corresponding cosine function, I'm going to put a u. Everywhere I have a minimum, I'm going to put an upside down u. So here I have a u, here an upside down u, and this is the pattern that's going to repeat. So in black right here is my actual secant function. So this is the graph that I'm looking for. And with all of that said, I can now go back and I can answer these relative mins and relative maxes because my relative minimum is going to fall right here at the bottom of these U-shaped graphs. So I know that my relative minimum is at this value 10. Okay? And my relative maximum is going to occur right here at the top of these upside down U-shapes. So these are relative minimums, and this is a relative maximums. So my maximums are going to fall at this value 4. Now look, this is counterintuitive, right? Because 10 is higher than 4, but 10 is my minimum, 4 is my maximum. The reason is it's because these u's or these upside down u's indicate where the relative minimum and the relative maximums are going to be for the secant function. All right, so we go back to this final step, which was the vertical asymptotes, which I've already drawn in here in black. Now I just need to find the equation for them. So it's going to be x equals in both cases. I want the nearest one to the left of my phase shift. So my phase shift was right here at 6 pi over 10. And I can see that my asymptote is 1 pi over 10 further to the right. So as I move to the left, this asymptote right here, which I'll highlight. So this asymptote is my asymptote to the left of my phase shift. And so I can see that that's going to be 1 pi over 10 to the left of 60 pi over 10. So that's going to be 59 pi over 10. So there's my left phase shift. And then my right one is going to be the one that's to the right of my phase shift. So to the right of my phase shift right here, I can see it's at 61 pi over 10. And so that's going to be 61 pi over 10. And that would be where my my next vertical asymptote is going to be. And so those would be your answers for this. And if you had to sketch what the graph looks like, it would be the graph here in black.